please join me in saying bienvenue Laura et bonne chance. Et merci.
So I was invited to speak here at TrySwift while I was still freelancing and looking for my next job. And I accepted the invitation because TrySwift is clearly amazing. And also because my perspective on Swift is similar to a lot of New Yorkers' perspective on New York. Namely that everyone wishes they could live here, it's just that they've got some personal constraints and can't right now. And my clicker's actually not working, so I'm gonna come over here. Here we go. So with Swift, here we go. Maybe you haven't used it yet because you were waiting for ABI compatibility. Maybe you really just had to target these exotic operating systems like Windows. But maybe if those constraints went away, you would move back over to Swift for sure. And then I accepted the position at Adobe, porting the Photoshop app to the iPad. Now, Photoshop on iPad is publicly stated to be not just Photoshop Lite, but actual Photoshop. And what they mean by that is that it is literally the same Photoshop code base running on your iPad. Now, Photoshop itself is 31 years old, which is a decade older than a lot of this year's interns. And it's a massive project that's been written in and maintained in and pushed all the way to where it is today in C++. So we wrapped that C++ core in Objective-C to bring the UI up to the iPad. So when I told folks that I'd gotten this job, I got a mix of congratulations, like, oh my gosh, Photoshop, that is so, so cool. And buttons, condolences. People would say like, oh, Objective-C, yikes. And then C++, oh, you'll be fine, you'll make it. Because it's one of those things that people just say in passing, right? Oh, C++, I hate it on principle. And a lot of people who don't write C++ take that at face value. I've only heard negative things about it, so it must be awful, right? It's better now, some of my friends who use C++ would say. It's, C++ 11 is very usable. So far, the biggest risk to me of taking this job was whether the benefits of the team and the product would outweigh the heavy personal toll that the language would take on my psyche. Now, from a learning perspective, I'm just going to give up and use the buttons. OK. Now, from a learning perspective, if you believe that something is terrible, if you believe that your subject matter is an incongruous relic of a darker and more memory-corrupt time, you're going to have to work a lot harder to learn it. It takes an awful lot of mental energy just to get yourself to crack open the study guide, to push play on that video tutorial, and then keep the tab in front of your screen. A big theme of this conference has been curiosity, which Jordan touched on as well. Effective learning depends on curiosity. And you know what squashes curiosity faster than anything else? That fear, that disgust. So also in this past year, I went to a series of conferences on domain-driven design, which are engineering focused, but at the very, very highest levels. They talk about patterns, they talk about architecture, they talk about naming, communication. There are very few lines of code. And I noticed that I was the only one at the conference who introduced myself as like, hi, I'm Laura, I'm an iOS developer. Other people introduced themselves by maybe the goal of their product or their role on their tech team. They didn't affiliate themselves with their tech stack. And I wanted that kind of broad, like, oh, I just build things with whatever tools are at hand, sort of savoir-faire. But oh no, oh, this tool is C++. Now, for me, I found that one of my favorite parts of being a programmer is honestly all of these quirky and thoughtful and hilarious people that I get to meet just because we happen to have very similar jobs. So I decided to spark my curiosity about C++ a little indirectly by going out, talking to folks with years to decades of experience in the C++ community and asking them why they're still there. So I overcame some shyness. I messaged some prominent C++ developers on Twitter, on Slack, and I asked them to video chat with me. I had really lovely conversations with wonderful people. Starting those conversations, though, was so much more nerve-wracking than even, say, starting a conversation with the person sitting next to you at a conference, and I do not expect you all to go do it. So I've gone and done it for you, and have some things to report back. Now, there were a lot of people who very generously gave their time to answer my questions and watch my talk run-throughs, so I just wanted to say a quick thank you to these folks, and any details that I've gotten wrong are 100% my fault. So, people that I talked with were all excited about the things that C++ let them build. It turns out there's a ton of jobs making really cool things and cutting-edge technology that require C++. Now, I know that if I put up a bunch of jobs from my company, you'd think that I was just here for that sweet referral bonus, so I'm going to post some stuff from Apple. Here, this is a senior software engineer, perception verification, machine learning, and AI. They want someone who knows modern C++ to interface with roboticists and researchers to evaluate the perception capabilities of a robotic system. Maybe we'll find out about that in a few minutes here today. It sounds so cool. Some of you might have entertained the idea of contributing to the Swift compiler, but like Yuki pointed out, you might have seen that it required Objective-C and kind of, no, thanks. That is such a bummer, because if you're curious about compilers and you got your curiosity squashed by apprehension about C++, that's a loss for the whole compiler community. Now, every C++ person I talked with mentioned performance. They're pushing the hardware as far as they can, either because the hardware is super, super tiny, like your embedded devices, or because it's using all of your processing to render very, very high fidelity 3D images while doing a bunch of collision detection in real time. Now, just last week, I was looking at, for example, I was looking at a data collection that was stored as a vector, which is a standard C++ library kind of wrapper around arrays to make them more dynamic. And the lookup operations were performed by iterating over all the elements in turn and comparing them against the thing that you wanted. And I wanted to change the lookup operation to be by a different key, and said, hey, while I'm here, I could just make this like a map, that thing that looks things up by keys, so that we're doing that instead of iterating over everything. And the dev advising me said, no, that would be a slower lookup. We want these items in contiguous memory, and maps get allocated on the heap. Now, Jordan mentioned yesterday that it's important to understand memory. We're going to get even more specific, because lots of people that I talked with were really excited about optimizing for the L1 cache, and that was not a thing that a word that I had heard for many years. So, processors manipulate data in a few dozen registers, which are like 64 bits each usually, and each core on your machine has its own set of registers that it does work on. But most meaningful programs have more data than will fit in their registers, so data is always being read into and written out of these registers. One way to measure performance is by counting the number of operations that those registers are doing. This is where people talk about your big O runtime. They mean if you need to do work on a collection that's 200 items instead of 100 items, do you have to do 200 times as many, or do you have to do twice as many operations? Or is it tens of thousands as many operations? Maybe it's just 30 operations. And that is an important measure because, yes, all other things being equal, fewer tasks take less time. But all other things are not equal because that data being worked on has to come from somewhere. How far away is it? I'm not talking about far in space, like is it on this side of the silicon or that side? But in between these lightning-fast registers and your disk, the chip pages data into various levels of your cache, and each cache has a different size and speed. The smaller ones are faster, the bigger ones are orders of magnitude slower. So the third level cache takes so much more time than that first level cache. First level is your L1. The L1 is literally, it's on the core that's doing all the work. It's right next to the registers. The L3 cache, it usually backs up all the cores. It's shared between all of them, but it's still on the chip. The heap, though, usually gets allocated in RAM, and RAM is that thing that you used to be able to buy and replace in your computer. It's that stick. It's not on the chip at all. And reading data from your hard disk, forget it. That's like going to mine an asteroid. It is literally millions of times slower than finding data in your closest cache. But you can ask, okay, so it's a million times slower. We're talking about a million times a nanosecond. Does that even matter? It's 1/1000th of a second. Well, yeah, in high performance environments like a VR headset, If you write code that's 100 times slower than it needs to be because you're not optimizing for your cache and you miss that 90 frames a second that the VR needs, your poor data management will literally make your users sick to their stomachs. And so sometimes that performance critical part means saying, yeah, you could get away with doing only 2 tasks rather than 500, and the code would be awfully pretty, but those 2 tasks are on the other side of the world. I can walk from here and back to every seat in this auditorium faster than you can walk to Chicago. I'm not gonna look very graceful while I'm doing it, but I'm gonna beat your time. Taking advantage of fast L1 caching is actually how Adobe's Lightroom does real-time rendering of photo manipulation sliders, which entail about 40 operations per pixel as you drag the contrast slider. What it does is it breaks up the work into chunks that fit into slightly half of the space available on the L1 cache, calls that chunk the source, does one transformation into a destination, then the destination becomes the new source, does another operation back and forth 40 times, it's finished that work, writes that out, brings in the next chunk. If you've ever enjoyed performance tuning a table view, you might actually like performance tuning in C++. Now, everyone that I talked with on video chat had real delight on their faces. This is why I chose video chat. I wanted to see their eyes light up when they talked about certain things that the language let them customize. It was always things I'd never thought about customizing. By far the most animatedly gleeful person got the most delighted look in their eyes when they were talking about custom allocators. Ooh. So if you're targeting a wide range of hardware where the number of registers, the size of the L1 cache, the cache replacement policies, the relative speeds of the different caches, if you want your product to have excellent performance on all of them, C++ is going to let you precisely target each chip's architecture. I got kind of nervous during the TensorFlow talk yesterday, like, oh no, should we actually all be writing Swift to do performant code? And so I went and looked at the TensorFlow code that is targeting their awesome custom hardware, and like, yeah, no, it's still written in C++. A fundamental value of C++ is supporting all hardware. Another developer that I talked with was so tickled about the C++ standard's continued refusal to define the implementation of signed integers. Now, if you formally studied hardware representation of integers, you might have learned something about ints being stored as 2's complement, where to get the negative version of a positive binary number, you flip all the bits and add 1. When people say it's 2's complement, that's what they mean. This is how pretty much all computers represent signed integers, pretty much. A lot of early computers used 1's complement, where the negative value of an int was just the same int with all the bits flipped. They don't add 1. Most of the 1's complement hardware went away in the late 80s, but the C++ Standards Committee is so hyper-conservative, and they are conservative in the radical accepting of everything sense. They want to run on all hardware, always and forever. But for them to agree that, okay, it took them until the upcoming C++ 20 standard to finally say, yeah, okay, we'll get better security, we'll get less obtuse associativity of integers. The proposal actually says we are being needlessly obtuse, and there's a bunch of other benefits. But this was a tough choice for them because it meant leaving out hardware. The jury's actually still out on how many bits are in a byte. If ternary architecture comes up, C++ is ready. Another chord that struck me when talking with folks is our interconnected history. Now, hanging out with C++ developers, it gives you a different perspective on the roots of Swift. One person I interviewed was like, well, of course Doug Greger's doing protocols on Swift now. 15 years ago, he was working on concepts in C++. And here, a decade later, he authors Swift's Generics Manifesto, which is basically a love letter to protocols. The folks contributing to C++, they all kind of know each other the way that a lot of the folks contributing to Swift all kind of know each other. A lot of the early Swift people were also C++ people. And you know what? They still read each other's papers. There's a lot of back and forth influence that has not gone away. Now, remember that proposal, the C++ 20, that I mentioned, that settles that 2's complement is actually the one true way to represent signed ints? Yeah, it's authored by J.F. Bastian, the C++ lead at Apple. So I want to tell you more about the people, because you can look up the top 10 things that are useful in C++ 17, but you can't as easily look up What's it like to be on a C++ team? Now, one real benefit that I've been surprised by has been the maturity of the community. C++ itself does not cause maturity. Let's get that out of the way. But anecdotally, it correlates with a lot of bits of maturity that I find important. Now, maybe this is specific to Photoshop, but I have not had to teach a single person on my team how to be polite on code reviews. This is always a thing that I pride myself on when I join a new team, and if it's a reason to hire me, I say, I will raise the level of professionalism of your team. I will model kindness. And on my team now, I have 10 years of professional tech experience, but when people are in meetings, I'm sitting there taking notes like, oh, that was a really effective way to say that. People with significant experience in the decade sense who are also thoughtful and kind are irreplaceable. Now, obviously, not all older developers are kind, and not all C++ developers are old, but there are more developers with decades of experience in the C++ world than in the iPhone app world. So even if they aren't any nicer on average, just by the numbers, it's more likely that you'll run into a truly kind person with 20 more years of programming experience than you have. No way is it worth passing up an opportunity like that over some language aversion. And one of the reasons I started looking at other tech stacks is because I was tired of always being the oldest woman developer in the room. And then I started going to conferences with a broader scope and met women in their 40s and 50s who were at Microsoft. And I was like, man, I didn't even know y'all were out there. And there's where they are. Like, I can be that wise older person in the Swift community for whatever value of wise, but if I want my own, I have to look elsewhere. And finally, a mature company is going to get how to support employees with kids. When I was job hunting, one recruiter from a Pittsburgh-based company told me that the company has annual retreats to resorts in Mexico, that this was a perk. And I said, like, oh, awesome. Like, so people bring their kids? And the recruiter said, well, I mean, I think one of the executive assistants has kids, and you know what? She stays home. Nobody has to go on these trips, okay? But companies that get kids, they do things like offer 6 months of maternity leave. They pay for backup childcare on in-service days. It is such a relief if you have kids or want kids to have a company that gets it. So I started this project out looking for things that people thought were just sparkling awesome about the language. So I asked everyone about delight, and I got mixed results. One person said, you know, it's complicated. I get that not everyone's going to like it. I don't think there's anything that I'm delighted by in this language. C++ is not a good language. All of these people write C++ professionally at extremely advanced levels. 2 of them speak about it internationally. 1 sits on the standards board. But more than glee or joy, what I found was deep respect. One person said, you know, it's dangerous in the way that all powerful tools are dangerous. And the analogy to powerful tools is especially apt because people who deal in powerful tools very much have a desire to make them less dangerous. People who work with chainsaws want to not lose limbs. People who work with software want to not lose their livelihoods. And C++ is constantly adding more safety. You know, Kate mentioned yesterday, we can measure progress more easily than state. And C++ has improved monumentally with C++ 11, and it's had releases every 3 years since. And when I first took this job, like I said, I was scared. I was worried about learning a fossilized, possibly dying language that might also maim me. But talking with people in the community for this talk, they're actually not living in a constant state of fear. I'd say things are kind of fine. Because I would say, you know, I'm giving this talk to people who practically sent me sympathy cards when they heard that I was going to have to use C++. And the folks that I talked to, their response was like, excuse me, why? Now, we saw Davi's deep dive into natural language processing. I'm going to bring the conversation back to English again to really illustrate this sort of gentle confusion that I found. You know, English is an absolutely absurd language to learn to spell and pronounce. It should bother you deeply that the teens don't start until 3 after 10. And did you know that some languages name these months predictable things like 9-month, 10-month, 11-month, and they're not even off by 2 thanks to Julius and his jerk grandson Augustus. English has a lot of history that makes it incredibly difficult to learn, but many of the roadblocks of communication, like the roadblocks of programming, they're not about language choice. I've come across Swift files that were absolutely unreadable, as I'm sure many of you have. I've come across C++ files that are plain as dirt, which for me is a high compliment. So C++ is old. It has baggage. It has legacy. But it's also spry. You know, it's moving forward. It's slowly, because they don't want to leave anyone behind, but it's making market improvements. These 3-year releases are major, and they're not going to break your production apps. So language choice does matter, but it's not the main thing. And if I had to choose, and I did, I'd choose people over language every time. And if you have a chance to join a phenomenal team that's working on a meaningful project, and they happen to be using C++, I really hope that you approach it with curiosity. I hope that it becomes not so much of a deal breaker as a data point, like your commute. Maybe it's still not a positive data point, but it's just another factor to consider when you're trying to decide what you're going to spend your time building. At the very least, you can have confidence that building ties in that development community and staying curious about its patterns, cognizant of its constraints, it's going to make you a stronger member of this one. And when you and the people around you, you start working together on the next high-performance paradigm-shifting language, you're going to get to draw from the experience of developers with decades of background in languages, while you push programming forward into something that we today can hardly imagine. I can't wait. Thank you.